Hi everyone! So today we are looking at the gradient of a line. So pretty much the gradient just refers to the steepness or inclination of a line or an interval. So think about it, if you're running on a treadmill, if you increase the inclination, your run then becomes steeper, right? Like your treadmill actually goes up, and that's because the gradient of your treadmill or line is increasing, which obviously means you result in a very hard run, which I don't do. So the gradient itself is always represented by this variable m, okay? So all the time it's represented using this variable m. It's calculated as a fraction, and it is on the top of the fraction is the vertical rise, and on the bottom of the fraction is the horizontal run. And this is between any 2 points. So if we think about a Cartesian plane, if we're thinking about the rise of a line, the rise represents these y values, right? So this line represents our y value, and our rise talks about going up that vertical line, whereas the run represents the horizontal axis, which talks about our x. Here we've got two types of lines in terms of like two different directions a line can take. If a line looks like this, we say it has a positive gradient, and that's because if we go left to right, the y values are increasing. So as you can see here, this y value versus this y value, as we go left to right, our y values are going up. As you can see here, this would probably have a y value of like, say, -2, and then this one over here would be 0. This one would be, say, 5, right? The y values are going up. So we say it has a positive gradient. And if you think about it, we're talking about the change in the rise over the run. So if the rise is getting higher, that means that it's going to be a positive gradient. Whereas over here, as we go left to right, our y values are decreasing. So our rise is getting lower, which means, well, that's the way you can think of it, which means it's a negative gradient, okay? So in terms of gradient itself, it's a fraction where it's named rise over run, where rise represents the y, the change in the y, and the run represents the change in the x. You will have to remember this forever, by the way. Rise over run, the gradient. Okay, so here I've got 3 lines. All of these lines have a positive gradient. As you can see, they all point in this positive direction, right? Which of these lines, though, would be steeper? So just because it's got a positive gradient, let me add, doesn't mean their gradients are equal. It just means it's positive. So whatever the number is, it's going to be a positive number because the gradient is actually represented by a number. So you could say the gradient is equal to 3, right? That's a positive gradient. Or your gradient is equal to -5. That's a negative gradient. And the number itself, like if we have 3 versus, say, 6, the number itself actually tells you how steep that gradient is. And we'll get to that in a minute. But in terms of these 3 lines, which of them would have a steeper gradient? Yes, it is the purple line. And imagine this is you, right? And you're running on a treadmill. Which one would you prefer to run up? I would choose the green one versus the purple one because check out how steep that bad boy is. No, thank you. All right, so here we've got 2 examples. The first one, calculate the gradient of the line. So for our first example here, we've got gradient, remember, is denoted with m, which is rise over run. And our rise in this instance is how far up are we going? And it's telling us that from there to there, it's 2 units, right? So it is 2 over our run, which is 6. Now this number here, you might remember from when we were doing the length of an interval, I think it was, and we had to find the values. Or was it only yesterday's lesson? They're all blending in together. Where we had to find that height and that height I think it was the length to help us find that height. Remember, this was the difference between the y values, and that's telling us the difference between this y value and that y value is 2. Whereas the difference between that x value and that x value is 6. Hence the run, which is the x, and the rise, which is the 2. So we can simplify that. 2 over 6 gives us a third. All right, and as you can see, we've got a positive number for our gradient because our line is in a positive direction. Whereas for this guy, you would imagine it would be a negative number. So let's have a look. Let's go m is equal to rise over run again. Now this time, notice how with the rise, because it's going down, in terms of this is a decreasing or a negative gradient, this distance and this distance will always be positive because we're talking about a distance, right? Like that's 4 units and that's 8 units. But it's up to you guys to recognize the direction of the line and say, well, that must be having a negative, I wrote rise, like a negative rise over here. Because it's going down, the y values are decreasing, which means this would be negative 8 for the rise over a run of 4, which is negative 2. And as we said, that is going to be a negative number because it's a negative gradient, okay? So rise is the y, run is the x. All right, question 2. Calculate the gradient of the line passing through the points 4, negative 2, and 4, 6. So here we've got A and B, and I've drawn the line through it for you already. As you can see here, what we can do is create that right-angled triangle again. I'll do it in pink, whereby this and that will form our triangle. And the reason why we do it is we say, okay, well, we want to work out what the difference is in the y values between this point here and this point up here, right? That y value is 2 and this y value is 6. So automatically you can imagine the y value and all the rise is going to be 4. That's right. So that's why we do this triangle. It's the same. You could do it over here really if you wanted to, like from there to there. What's that gap? So that's 4. And then this one, and it's the same as counting, right? Like if you go 1, 2, 3, it's 4 units. And our run, we're going from this value, this point here, to this point here. So from negative 4 all the way through to positive 4, it's going to be a distance of 8. So our gradient, again, is rise over run, which equals our rise is 4 over our run, which is 8. And that leaves us with a half. Again, our gradient is positive and our answer is positive, so that's good, right? Okay, the sign and the size of the gradient. So ignore kind of down the bottom for a minute. I've got here, the sign of the gradient tells us if the line is sloping upwards or downwards. So as you can see here, this gradient is positive and that gradient is negative. The sign of this one is a positive sign and this is a negative sign, right? Like that's a negative, that's a positive. So when it's talking about the sign, you're saying if it's positive or negative. So if it's positive, it's sloping upwards, and if it's negative, it's sloping downwards, okay? So that's the sign. The size of the gradient tells us how quickly the line is going up or down. So this tells us the steepness of the line. The higher the number, the steeper the line, okay? The higher the number, the steeper the line. You're ignoring the fact whether it's positive or a negative number at the moment, and you're just looking at the size of the number itself. So remember, if we say negative 4 versus negative 5, we know that negative 4 is a larger number in terms of like on a number line, right? But the number itself, if we ignore the negative sign, that's only telling us if it's positive or negative, and we already know it's negative, but the 5 is actually the higher number, if that makes sense, because the size is only telling you if it's a positive or a negative gradient, okay? The sign, sorry. If the gradient is equal to 0, what this means is the line is horizontal, so it's got no gradient, it's flat. All right. Which gradient is steeper? out of each of these examples, so A and B. So our first example that we've both got positive gradients, so which of these gradients would be steeper? Well, remember, it's the one with the higher number. So that would give us, ooh, I did not want that colour. That would mean a gradient of 10 is steeper than a gradient of 5. For example, over here, we could say that this would have, say, a gradient of 5 versus this one might have a gradient of 10 because it's a steeper line. Alrighty? Whereas for the negative gradients, even though both of these are negative, remember it's the larger number. So that would still mean that negative 10 would have a steeper gradient than negative 5. And the reason for that is, have a think. Come over here to my think box. First of all, I mean, the positive gradients are kind of easy to think about, but looking at the negative gradients, if we've got m is equal to negative 5, we can write it as negative 5 over 1, right? Which means the rise is negative 5 and the run is 1. So it's going down 5 units for every across 1. So it's going down 1, 2, 3, 4, 5 for every across 1. So our line would look like that. Whereas for negative 10, it's going down 10 units for every one across. So in terms of looking, I'll rub this out for you, but we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh no. Running out of room. I was just going to show you in terms of what it would actually look like. But you'd have something like this, right? So it's going across 1 and down 10. Whereas for 5, it's going across 1 and 1, 2, 3, 4, 5. There you go. It's hard to tell, but look how they're not, like, they're different steepnesses. That was a really bad example, but you'll see what I mean. I hope the logic of this makes sense. Like if you're going down 5 and across 1 versus down 10 and across 1, it's steeper. Okay, so the formalities. We cannot forget the formalities. Like I said, this diagram is going to haunt you forever, so it's good that you make sense of it now until forever, I guess. So the vertical rise, remember, represents how high or the difference between these 2 points. So if we're looking at the difference in the height between the 2 points, that's the difference in the y coordinates versus the difference in the x coordinates for the run component. So if we don't have a picture to count the grids, we can actually work it out algebraically. And the way that we do it is for the rise, we take the difference between the y coordinates of each point, and for the run, we take the difference between the x coordinates of each point, okay? So this helps us calculate the gradient if we're given 2 points. Something that is really important is that notice how on the top we've got y2 minus y1, and then on the bottom we've got x2 minus x1. Now they come from the same coordinate and they come from the same coordinate, which means you have to put, if you're putting the first y coordinate, like whatever y coordinate you put first, you have to put that same x coordinate first on the bottom, okay? So if that's first on the top, the corresponding x coordinate must be first on the bottom. It does not matter which order you do it in. It just has, like in terms of this point versus this point, right? Doesn't matter, just as long as you keep them the same. So for our formalities, find the gradient of the interval joining the points. So remember our gradient, all it is the difference in the y coordinates over the difference in the x coordinates. Like I said, it really doesn't matter. So here we've got negative 4, 2 and 4, 6. All right, let's just call this one the first one. And we'll call this one the second one. Okay, because I'm going to take y2, that's 6. So I'm going to go 6 minus 2. So it's one y coordinate minus the other, all over Now, I have to take this x coordinate first. I can't take that one because I took this as my first y coordinate on the top. I have to take that as my first x coordinate on the bottom. So it's going to be 4 minus, because remember the minus is a part of our formula because we're trying to find the difference between the 2 points, minus the second or the other x coordinate, so minus 4. Watch that double negative. So on the top, we've got 4, and on the bottom, we've got 8, which is equal to 1/2. And you may have already noticed, but these were actually the 2 points that I used over here, and we still got the same answer. Obviously, it's easy to have a look here by counting the units. We can go rise over run, 4 over 8. But if you don't have a picture, you can just say, well, it's exactly the same as taking the difference between the y coordinates and putting it over the difference between the x coordinates. And there you go. That is gradient for you, ladies and gentlemen. Good luck, and let me know if you would like any assistance. And just want to let you know this is how I run on a treadmill.